Today we will look how to solve problem with a motion along a straight line with uniform acceleration. To solve those problems we will need to use four main formulas. Final velocity equals initial velocity plus acceleration times time, formula number 1. Displacement equals initial velocity plus final velocity divided by 2 times time, will be formula number 2. Displacement equals initial velocity times time plus at squared over 2, that will be formula number 3. And final velocity squared equals initial velocity squared plus 2 times acceleration times displacement 4. Using those formulas we can solve about 95 problems related to the straight line motion with the uniform acceleration. But in some cases we will need a couple other formulas. One formula can be derived from those formulas is displacement equals final velocity times time minus acceleration t squared over 2. And most important, the formula that we will need to use either when we have a problem related to the motion of two objects or more, and when direction of the motion changes. Because except formula 1, all others can be applied when direction of the motion not changing. If direction of the motion is changes, or if you're dealing with a few objects, then the best will be to use equation of the motion that gives us position of the object at any time, and we take into account the initial position of the object plus initial velocity times time plus acceleration t squared over 2. And we need to remember that all those values, velocity, acceleration, displacement, they all vector quantities. So we need to take direction into the account. Let's consider application of those formulas on some examples. First, before we look into the first example, we can realize that there are 4 variables in each formula. So each formula connects 4 variables. Altogether we have 5 variables describing motion with a uniform acceleration. It's initial velocity, final velocity, acceleration, time, and displacement. Each of those formulas has 4 of them. And usually in the problem that we need to solve, we have 3 of them known, and we just need to identify which of those formulas connect 3 known values with 1 unknown. So, example. Jake starts from rest. We immediately can notice that the initial velocity equals 0. At the top of 3.2 meters, so it will be 3.2 meters, displacement at the top of 3.2 meters long playground slide and slide to the bottom with a constant acceleration. It takes 2.4 seconds to reach the bottom. We need to find acceleration and we need to find his final speed. So let's start from acceleration. So we have known values u, s, t, and looking for a. The formula that connect those values is number 3. So let's apply this formula. We have s 3.2 meters equals 0 times 2.4 plus a times 2.4 squared divided by 2. Solving for acceleration, we'll get approximately 1.1 meters per second squared. To find velocity, we can now use Formula 1, but it will be better not to use it because acceleration, the value that we have found, is a rounded value. And then, using rounded value, we will get value for velocity that might be a little bit off. So let's have a look. Try to use, and in all problems you need to try to use given values to find something unknown. So formula connecting U, S, T and V is formula number 2. So let's apply that formula. T equals 2.4 seconds. So we have 3.2 meters equals 0 plus V divided by 2 times 2.4. Solving it for V will give us 2.7 meters per second. Now let's consider another example. Michael Jordan have a vertical leap of 1.29 meters. Then, what is his takeoff speed? So we need to find his initial velocity, and also we need to find his hang time. So how long he will be in the air. Also, even if it's not directly expressed in the problem, we have 2 more values. First, we know his acceleration, because his acceleration due to the gravity equals 9.8 meters per second squared. Also, we know his final velocity, because at the highest point his velocity will be 0. Otherwise, it will not be the highest point, he will continue to move up. So to find initial velocity, if we know final velocity, acceleration and displacement, we look through those formulas. The formula number 4 connects them. So we have 0 final velocity. I will first solve it in general. So we have the 0 equals u squared plus 2as, but let's choose axis up, so acceleration is down, so it has to be negative u squared minus 2gh, and we get formula u equals square root of 2gh. Substituting values in the formula will give us value for velocity 5.03 meters per second. To solve the second part of the problem, to find time, we need to realize that if we disregard air resistance, and in our course we will be disregarding air resistance, his motion is perfectly symmetrical. How long it takes him go up, that long it will take him to go down. So we have, in fact, he in a free fall from the height 1.29 meters with now initial velocity equal 0, and we will need to find his time. So we can now use this formula. We have that h equal initial velocity is 0 because at the highest point he is stationary, and now when we consider his way down is that velocity at the highest point is initial velocity. So h equal gt squared on 2. From here, rearranging it for time, we'll get time equal square root of 2 times height divided by acceleration due to the gravity. Substituting numbers, we'll get the time equal 0.51 second. But that is the time only to get down. The total time will be twice that. So answer to the question will be time equal 1.02 seconds. Now let's consider another example when we will need to use the equation of the motion. So let's consider the next problem. Stone thrown vertically up from a cliff 17.5 meters high. It's thrown with the initial velocity 21 meters per second. Questions are: how long it will take to reach to the ground at the base of the cliff? And second question is, what will be the velocity of the stone when it's hit the ground? And the third question will be, what is the maximum height above the ground that the stone will reach? To solve this problem, let's make a small diagram. Let's take 0 position at the ground level. So that is initial position of 117.5 meters. And initial velocity is up. So it's moving up and then falling down. Taking in the account that we're taking in 0 position at the ground, we can write the equation of the motion, that position of the stone at any time x equals initial position 17.5 plus 21 initial velocity, and it's positive, we take positive direction up, 21t minus 9.8 t squared over 2. Why we take in minus? Because acceleration is down, and we take positive direction up. When it's hit the ground, it's going up and then hit the ground, its position becomes 0. So we need substitute 0 here and solve this as a quadratic equation. When you solve a quadratic equation, the best is rewrite it with a squared term positive. So let's rewrite it as 4.9 t squared minus 21t minus 17.5 equal 0. Let's apply quadratic's formula. T equals 21 plus minus square root of 21 squared plus because in the quadratic's formula it's minus, but we have this minus becomes plus 21 squared plus 4 times 4.9 times 17.5 divided by 2 times 4.9. When we do calculations, we can get if you use minus, you'll get negative time. That doesn't make any sense. So we disregard that. We use only plus, and calculations will give us the time equal 5 seconds. So it will take 5 seconds for the ball to go up and then drop to the bottom of the cliff. To find the velocity with which it hit the ground, the best will be use formula number 1. V equals U plus AT. So that V will be equal 21 minus 9.8 times time that we have just found, times 5, and we will get a negative 28 meters per second. The negative sign means direction, that the final velocity will be directed down. So if the question is speed, answer will be 28 meters per second. And to find maximum height, we can use the fact that the highest point, the velocity of the ball is 0. And we can use the formula that S equals the best will be use formula V squared equals U squared plus 2GH. So we have 0 equals initial velocity 21 squared minus, because again initial velocity up, acceleration due to the gravity down, minus 2 times 9.8 times height. Calculations will give us the height equal 22.5 meters. So the total height above the ground that the stone will reach, we need to add its initial height 17.5 plus final 22.5, and we'll get answer 40 meters. Let's consider one more example when we need to use equation of the motion. Let's consider motion of two objects. When we will need to write equation of motion of each of them. A man runs at a speed of 4 meters per second, at a constant speed, 4 meters per second. To get into the standing bus. When he is 6 meters behind the bus moves forward and continues with a constant acceleration of 1.2 meters per second squared. Question is, how long does it take for the man to get into the bus? So, to solve this problem, let's take the initial, take 0 where the man was initially. So position of the bus will be 6 meters. Equation of the motion of the man will be x equals, he moving at the constant speed, so just 4 times t. Equation of the motion of the bus that's man. Equation of the motion of the bus will be initial position is 6. Initial velocity of the bus is 0. So plus 1.2 t squared over 2. When men catch up the bus, their positions become the same. So we can equalize the expression for the position of each of them for t equals 6 plus 1.2 t squared over 2. And again, we will get quadratic equation 0.6 t squared minus 4t plus 6 equals 0. We again can apply quadratic's formula. T equals 4 plus or minus square root of 4 squared minus 4 times 0.6 times 6 divided by 2 times 0.6. In this case, we will get two solutions, two positive solutions. We will get that time, if we're using minus, we will get 2.3 seconds, and with a plus we will get 4.4 seconds. Let's think what is the sense of the two solutions in this case. The first solution will be when men initially catch up the bus and get on. But if for some reason he will not get on and decide to continue to run, he will overcome the bus. But because bus accelerating at time 4.4, now the bus will catch up the man. That's all.